Today I'm going to talk to you about food colors and some of the surprising places where they're found and the obstacles to knowing how good or bad they are for you. A topic of conversation between parents, teachers, and health professionals since 1973, when Dr. Ben Feingold presented his hypothesis of the biochemical basis of behavior to the American Medical Association. In the U.S., the argument has gone back and forth about the effect of artificial dyes like red 40, yellow 5, and yellow 6 on our kids. But I also think this is a topic that every voter needs to think about because the FDA is headed by a political appointment. So it is important to elect an administration who prioritizes science and preventative health over flashy medical innovations and small cap startups. In short, there are synthetic dyes and natural dyes. Natural dyes do not maintain their color as well at cooking temperatures and in general absorb more light, so they need to be used at higher concentrations, and some impart some slight tastes. Some natural dyes include cochineal red, also called carmine, which comes from beetle carapaces, nature's way of saying don't touch, and we use them for dyeing fabrics, makeups, and food long before we settled this country. Also, turmeric is used for gold tones, and annatto is used for yellows. The FDA does not approve natural dyes. They are labeled as natural colors. There are 9 artificial dyes approved by the FDA. They carry the initials F, D, and C for food, drug, and cosmetics. The FDA makes distinctions between topical and ingested drugs, as well as cosmetics and eye cosmetics. As it should be, ingested drugs and eye products carry a higher standard. As you can see, they have many names by which they are called on a given label. One has to put a lot of care about their consumption to learn all the aliases and know exactly what they are consuming and feeding their families. Most of these dyes are also available as lakes. Lake is a metal bound to a dye. Red 40, yellow 5, and yellow 6 are the most common dyes used in the U.S. and are all often used as lakes to intensify their color. Aluminum is the most often used, but other metals are used as well, and labeling does not require a distinction in the substrate used. The light reflectance of the metal substrate makes the colors brighter. The EU has a much tighter restriction on the use of lakes. The best traction on the topic of food additives in our kids comes in the form of 2 studies conducted in the UK related to artificial dyes in children's behavior. These were credible enough to bring the European Union to require that foods containing artificial food colors must carry a warning label that the product might cause hyperactivity and inattentive behavior in some children. So here are the citations of those 2 studies for anyone wanting to go to the source. About these, Alison Schwanwald, editor of the American Academy of Pediatrics' Grand Rounds, remarked in 2008, quote, "Thus, the overall findings of the study are clear and require that even we skeptics who have long doubted parental claims of the effects of various food on the behavior of their children admit we might have been wrong," end quote. So here in the U.S., the FDA convened a panel to study these findings, and in a 6-to-8 vote, they chose to not put the label on our food products at this time, but called for an investigation into, quote, "robust intake estimates," end quote. So let's talk about how much we do consume. Dyes are obvious when in a bowl of Fruit Loops or a bag of M&Ms, but let's look at where we don't expect them and how much we do consume when we think we're being healthy. So regular Eggo blueberry waffles don't have color added to them. But if you buy the Nutri-Grain blueberry, you're going to get a load of red 40 and blue 1. If you're taking a multivitamin in the morning, you need to take a look at the label to see what dye was used to give it its color. Toothpastes are also dyed. Even white toothpaste may have a blue pigment to make it brighter. Those cute, convenient cracker sandwiches we send in our kids' lunch boxes, and some brands of bread are among the baked goods given a more eggy whole wheat look by having yellow dyes added. The flavored milks are not always real strawberry or chocolate colors, and despite the fact that cheese has been dyed with annatto for generations, Kraft mac and cheese is not dyed that way. It is loaded with yellow 5 and 6. In 1950, the FDA set the allowable exposure of artificial color to 50 milligrams per capita per day. It was reset in 2012 to 62 milligrams per capita per day. The EU and WHO recommendations for consumption are based on milligrams per kilogram of body weight. This is really the ideal way to deal with it because children are so small and they have immature digestion and immune systems. one of the major points of the American Pediatric Academy's policy statement, which I'm going to discuss shortly. It is not uncommon for an average American kid to easily consume 100 to 200 milligrams of food color a day. If they consume candy, they are more likely hitting the higher end of this or possibly exceeding that range. Bateman and McCann published over 10 years ago, and we're not rushing to resolve this issue with better analytical or genetic studies, but that doesn't mean nothing is changing. I want to talk about two publications. The first is a policy statement from the American Pediatrics Academy, which makes a clear and strong recommendation to require more of the FDA. So in essence, this is a call for political will and amendment of laws by Congress. They criticize the FDA's inability, as in they have no jurisdiction, to call for review of anything on the generally recognized as safe list. The GRAS list, as it's called, was established in 1958, and it grandfathers items once they're added to it. So once something's added, it is immune to scrutiny. The APA is also critical of the basis of industry-supplied safety data. Although the pharma and med device industries do the same, the significant differences here are that a whole lot more people are impacted by food products. And additionally, and possibly more critically, food additives and processing agents have no aftermarket surveillance, which is inherent in these other industries and paid for by the other industries, not by tax funds. The FDA admits it doesn't monitor produce for the use of food dyes, although dyed strawberries would be adulterated. They have never monitored for it, and therefore they will never prosecute for it. The second article was published just last month. It's interesting. It's essentially an environmental safety study, but it uses childhood food additive research in its background and uses 3 established genetic models. And it looks at the effect on the development of these species across 4 food dyes, 2 of which are allowed in the U.S. and 2 of which have been banned in the U.S. And they apply the recommended concentrations for cooking with heat. So it's 600 milligrams per 500 milliliters, which is what the dye additive makers recommend for cooking. So these dyes include cochineal red, also called carmine, which is allowed in the U.S. and until 2009 could be just labeled as natural colors as a bulk label on food. But now, due to severe allergic reactions some people have, the FDA requires either cochineal extract or carmine to be labeled explicitly. The other color is called Poncio or cochineal red A, which is a synthetic of the natural pigment, and this has not been approved for the U.S. Tartrazine, which is FD&C yellow 5, is one of the items looked at in the study, and it's been known to cause allergic reaction in some people. And there have been several studies that looked at the concurrence of asthma and yellow 5 sensitivity. So there's a study of 99 women with histories of atopic allergies, and of those, 6% had reaction to tartrazine. And the final color looked at is patent blue 5, which is not allowed in the US, but is in the EU. These were applied to the cucumber, the brine shrimp, and danios, also known as zebrafish. Details of the controls, the number of samples, batches, the use of mineral water in solutions, sterilization of seed surface, pH adjustments to the various species. If you have insomnia, all the details established by institutional practices are in the report. But the important part here is why these samples were used and what was observed. So the cucumbers were recently decoded genome, and it's used as an indicator species for plants. Brine shrimp are a hearty species of crustaceans that exhibit sexual dimorphism and are resistant to a lot of environmental stressors. And they haven't changed much since the Triassic period, but they have a history of being used as an indicator species in human cytotoxicity studies. So danios, also called zebrafish, have been established as a genetic model for human neurology and neuromotor studies. So zebrafish have 70% of the same genes as we have, and 84% of the genes we have linked to human diseases have a zebrafish counterpart. So here's the results from the study. Each species had reactions to the food colors. We're going to go through each species independently. So the danio eggs were observed for the time to which they hatched. So all the eggs hatched by 78 hours post-fertilization. So they went about half that time, and they took the data to compare the different species. So at 48 hours, the Poncio, yellow number 5, and patent blue were all hatching at substantially faster rates than the control and the carmine treated species. Also, they looked at the embryos 72 hours after they hatched. So structural deformities were evident in the embryos treated with the Poncio red, the yellow number 5, and the patent blue. I'm going to show you some photos of some of those deformities in a moment. We also want to note they were looking at the heart rate of the little fishies as well, and they were elevated for species exposed to Poncio red and patent blue. Keep this in mind because when we get to some of the other species, you're going to see some growth rate, development changes, and also some things that indicate some metabolism problems. So just keep that in mind. Okay, so these are your results for your danios. And in the far upper right is the graph that goes with the hatching, where you see the control in white and the carmine paralleling that with less than 20% hatched at 48 hours. So this is about halfway through the incubation period of an egg becoming an embryo that's hatched. And compare that then with where you're like 70 to 65 for the Poncio red and the yellow number 5, and maybe more like 30 or 25 to 30 on the blue. So these are much more precocious in their growth. So in the half the way through the incubation time, maybe 1 out of 5 of the controls has developed fully. And for those treated, you're looking at the majority of them already hatched halfway through their incubation period. Alterations, I'm going to wait till last. The middle graph there goes with the photos. And the last one is the heart rate. And so you can see the slightly elevated Poncio red and patent blue in the heart rate, which was mentioned. So on the alterations, there's nothing shown on that graph for the control or carmine. And that's because they did not have deformity. So they're going to manifest like that far left column with those, it's labeled control, CONT, with a nice straight spine, no deviations left or right in the tail. They've got a defined head with a nice big eye and the thorax. And that is what a danio is supposed to look like. And so the carmine and the controls were able to do that. And then you've got your alterations in the others, and you have a mix of them. So in all 3 of the colors that had alterations, they all exhibited deformations of the spine and the tail. So where you lost symmetry, so like a hook to the left or a hook to the right, or some other misdevelopment of the spine. And then the other item that they have is they refer to it as edema. It's those large swollen bellies and irregular masses, many of which are symmetrical and some that are not. And then the third type of mutation they had was only seen with the blue down in E131, and that was referred as microcephaly, where the head is not clearly defined as separate from the thorax. The head is much smaller than it needs to be to hold the eyes. Some real head development problems. Okay, we're going to look at what happened with our cucumber now when it was exposed to these concentrations of food dye. They looked at the seed halfway through its germination point, and the only one that seemed to be out of norm with the control is the yellow 5, which looked like it was delayed in its germination. They also had bisected them at this point to determine how their germination was going, and they looked at the seed coat, both the morphology of the individual cells as well as the thickness of it, and those all seemed to be within the normal bounds. They let the remaining samples sprout, and then they looked at the behavior of the growth of those sprouts. They looked at the length, the depth of the root, and also the length of the shoot, and compared some ratios. So the ratios are off for the carmine and the Poncio and also the yellow 5, and make it look like there might be inadequacy in supporting the shoot. not enough root to support the shoot. And then there's the ratio looks good for the blue, but if you look back in the data, you're going to see this guy grew very, very fast. His ratio of root to stalk is appropriate, but he was like 15% larger than the control across the board there. And they also then looked at the chlorophylls. And for your carmine and your blue, you've got a pretty large density of chlorophylls. So this looks kind of like maybe that plant's upregulating the amount of chlorophyll it has. And then they looked at, along with that as an indicator of photosynthesis, they looked at the carotenoids as well. Those parallel what they saw in the chlorophylls. And then they looked at antioxidant activity in the plants. All of the food dyed, treated, have a significant lack of antioxidants being generated. So for the brine shrimp, they looked at mortality, mobility, any abnormal anatomical features, and the phototactic response, which is sort of a reflex response that the brine shrimp have to light. So when you turn the lights out, they kind of get very comfortable, they spread apart, they start wandering, getting their own space, and as soon as you turn the lights on, they kind of group together and kind of flock, and it's a sort of inbred reflex response they have. So the results of these guys after treated with the food dyes is that the patent blue and Poncio red at 7 days had almost twice the mortality rate of the control in carmine. And that's visible in the lower left, far lower left graph. And you can see that the carmine sort of parallels the control, and then the others are offset. Next to that, just to the right of that, you're going to see the mobility data. And what you'll see there is that the Poncio red and the yellow 5 and the patent blue had significant mobility losses compared to the carmine and the control. So all the shrimp developed regular heads, antennae, and body parts with no signs of swelling or gross deformities. About 5% of those exposed to yellow 5 and Poncio red overdeveloped their thoracopods. And those are seen in the picture. So E102 is the yellow and E124 is the Poncio red. And along the thorax, you can see those little nubs that are not particularly defined in the control or in E120, which is the carmine, and then kind of are very large for the other two, and not even necessarily symmetrical left and right. And you're going to see in the E124, which is the Poncio red, that they're almost elongated like appendages. And so it's about 5% had those sort of deformities. And there was no difference in the phototactic response to any of the colors after being treated with the food dye. So regardless of whether we're talking danios or cucumbers or shrimp, we see some development rate issues. We see some ratios or proportions that are off, and some effect from food dyes. So then you question, should I be concerned? And I don't know. As a parent myself and someone who works in the health area, healthcare with people with compromised immune systems and autoimmune diseases, and certainly little people, I would like to see more information. To be devil's advocate here, you know, we did say that the WHO and the EU defines maximum consumption in the amount per kilogram body weight. So is it fair that a little danio that's like maybe 1/5 of a gram in weight gets a full human dose? I don't know. But if we're proving that dosage has some effects, high dosage, then it kind of underscores the statement that what happened to that consumption data asked for by the FDA panel in 2008? So it's 11 years later. I have no idea what my consumption is. Labels do not give you adequate information to know that. So I do personally believe that more investigation is appropriate. It may not happen without regulation, But I do believe that that would create an opportunity for other people to step forward and do things differently, possibly for less profit, but giving additional products on the market. So as consumers, especially of something like food that you're going to buy one way or another, you're going to buy food. Your choice is which foods you buy, not what's on the market for you to choose from. So, and I'm going to stop there because I've just opened a whole big can of worms, and we need to figure out what we want to do about it as consumers. And I'll leave you with this last citation, and underneath is the link for the full document from the American Academy of Pediatrics and their policy statement on food additives and child health, which is a pretty definitive statement about what they think needs to change in the FDA, which is why I shared this with my state representative. And you're welcome to do that as well. Thank you. Thanks for listening to me rant.